I want to start today with a feeling. It's a very specific sensation, and I'm willing to bet that, well, pretty much everyone listening has felt it at least a few times this week.
Okay, I'm intrigued. What's the feeling?
It's the sensation that modern life is shrinking.
Shrinking. Huh. That's an interesting word for it. I mean, usually people say accelerating.
Well, sure, it's fast.
Yeah.
That's obvious. But, I mean, the sensation that time itself is contracting. It feels like technology is moving so much faster than our ability to, process what happened yesterday.
Right.
That we can't even begin to plan for tomorrow. We're just reacting all the time.
That is the defining sensation of our era. And you're right, it's not just in your head. I think we often talk about burnout or overwhelm as if they're like personal
Oh,
failing.
totally. Like you just need to meditate more or get a better planner.
Exactly. But when you look at the sociological data, that feeling is structural. It's built into the very architecture of the system we're all living in.
And that's exactly what we're digging into today. We are looking at why we feel this way, but we're doing something a little different. We're not just doing a sociology class on, why we feel rushed.
No.
We are looking at a massive collision that is, I think, about to happen.
This is where this deep dive gets really fascinating for me. We have these two massive forces rushing toward each other like freight trains. On one side, you've got the sociological reality of future shock and social acceleration.
Which is basically society moving too fast for the human psyche to keep up.
Precisely. And then on the other side, we have this technological reality. We're seeing AI enter a phase that people are calling recursive self-improvement.
Which, if I'm getting the sources right, is where machines literally start teaching themselves, and they do it way faster than any human can follow.
Correct. So on paper, it looks like we're heading for, well, infinite speed.
But, and this is the twist that really hooked me on this whole topic, just as this acceleration threatens to go completely vertical, to go infinite, we are hitting a physical barrier.
A wall.
The data wall. The data wall. It turns out we are literally running out of human-generated text to train these systems on.
It's such a perfect, ironic bottleneck.
So the mission for this deep dive is to try and understand the velocity of this moment. Are we about to hit a singularity of speed, or are we about to stall out because the engine is running out of fuel?
And to figure that out, we've pulled together a really diverse stack of sources. We're going back to the classics with Alvin Toffler's Future Shock and the Third Wave.
And we're pairing that with Hartmut Rosa's more modern classic, Social Acceleration.
Then we're smashing that together with some pretty heavy technical forecasts. We've got reports from the Marketing AI Institute featuring insights from former Google CEO Eric Schmidt.
Plus some really deep data research from California Magazine, that's UC Berkeley's publication, and a projection paper from an organization called Epoch AI.
So it's a real collision of sociology and, hard computer science.
So let's start with the diagnosis. Why do we feel like we're losing our minds? I was honestly surprised to see how far back this goes. We're talking about Alvin Toffler. 1970, Future Shock.
Yeah, 1970. It's wild how prescient he was.
Right. I feel like that term gets thrown around a lot. But what did he actually mean by it? It wasn't just, oh, I'm surprised by new gadgets.
No, not at all. He defined it as a very specific psychological state. He called it, and this is a bit of a mouthful, the shattering stress and disorientation that induces psychobiological illness.
Whoa, hang on. Psychobiological illness. So he's saying the speed of change, what? It actually makes us physically sick?
That was exactly his point. Yes, he argued that we, as humans, we have a biological limit to how much change we can handle. You overload the system.
The human system.
The human system. You force someone to adapt to too many new things, too many decisions in too short a time, and the body it floods with cortisol. You get decision fatigue. You get apathy. You just want to withdraw.
Too much change in too short a time. That feels like the actual slogan for the 2020s.
But 1970 wasn't exactly slow, right? What made his prediction so different from just, an old man yells at cloud kind of thing?
Well, Toffler's core argument was that technology and culture were accelerating so fast that they were outpacing humanity's biological evolution. I mean, we are still, biologically speaking, hunters and gatherers.
Right. Our brains haven't had a hardware update in a while.
Not in a long, long time. But he predicted what he called a throwaway culture, transience in relationships, disposable goods, fleeting trends. He saw a world where almost nothing is permanent.
Which is basically the gig economy and TikTok trends in a nutshell. It honestly feels like he wrote a prophecy for 2026, not 1970.
It really does. And to get your head around where we are now, you have to look at his framework of the waves. He saw history moving through these massive society-altering shifts.
Okay, so the first wave was agrarian.
The first wave was agrarian, farming, connection to the land. For the most part, change happened over centuries. If you were a farmer in, say, 1400, your life looked a whole lot like a farmer's in 1450. The pace was glacial.
Right. And then the second wave hits.
The Industrial Revolution, that's your second wave. Mass production, standardization, the clock, the factory. Life definitely sped up, but it was linear. It was predictable. You clocked in, you clocked out.
And now we are squarely in the third wave.
Exactly, the information age. Toffler saw this coming way back in 1980 with his book, The Third Wave. And this era is defined by decentralization, customization, and what he called the prosumer.
Where the line between the producer and the consumer just kind of blurs.
It completely blurs. But the key characteristic of this wave, especially now, is turbulence. We are living through the transition, and that's what creates this immense friction and, well, this feeling of future shock.
Okay, so Toffler gives us the diagnosis of the shock, but I really want to drill down into the speed itself, because sometimes it feels like a total paradox. We have all these gadgets to save us time, right?
Yeah.
I have a dishwasher, I have AI that can summarize my emails, I have Uber. I should have way more free time than, I don't know, a medieval peasant. So why do I feel like I have less?
That is the central paradox that the sociologist Hartmut Rosa addresses in his work, Social Acceleration. He calls it the iron cage of speed.
The iron cage, I like that.
He argues that we are all caught in this self-reinforcing cycle. It's a trap.
Okay, walk me through that. How does saving time lead to having no time? It sounds completely backwards.
So Rosa breaks it down into three driving processes that feed each other. First, you have technical acceleration. This is the obvious stuff, faster transportation, instant communication.
Right. We speed up goal-directed processes.
Exactly. And the logic behind that is always time is money, right?
Yeah.
Efficiency is king. But that leads directly to the second process, which is where the trap really snaps shut. And that's the acceleration of social change. Rosa calls this the contraction of the present.
Okay, I loved this concept when I was reading the notes. The contraction of the present. Can you unpack that? Because it sounds almost poetic, but I think he means something very, very specific.
He does. It's the idea that the time frame in which your skills or your knowledge or even your social expectations are valid is shrinking.
Okay, give me an example.
Think about it. In the past, if you learned a trade, say you became a blacksmith or even an accountant in the 1950s, that skill set was basically valid for your entire lifetime.
Maybe even for your kid's lifetime.
Maybe even for generations. You could rest on that knowledge. It was stable.
And now?
Now, if you learned a specific software stack 5 years ago or a marketing strategy 3 years ago, it's arguably obsolete today. The present, that time window where your knowledge actually works, is contracting. It's shrinking. So you're constantly forced to relearn just to stay relevant.
God, that hits home. It feels like every 6 months there's a new tool everyone is using, and if you don't learn it, you're a dinosaur.
And that leads directly to the third form of acceleration, the acceleration of the pace of life. This is the subjective part. This is the feeling you started with.
The feeling of being crushed.
Yes. Because the world changes so fast, that's the social acceleration. And because we can technically do things faster, that's the technical acceleration, we feel this intense pressure to cram more actions into every single unit of time.
So we're trying to do more things in less time, not because we want to, but because...
Why?
What's the driving force?
It's fear. Rosa argues it's the fear of the death of missing out. If the world is changing every second, then standing still feels like you're dying. You're falling behind. So we run faster just to stay in the same place.
So we're trapped in this loop. We invent tech to save time, which speeds up social change, which then forces us to speed up our own lives to keep up, which makes us demand even faster tech.
Exactly. It's a flywheel. And up until now, that flywheel has been spinning incredibly fast, but it's been pushed primarily by humans.
And that brings us to the technological reality of right now. Because if we thought social acceleration was fast before, we are about to introduce a brand new engine into this system.
This is where it gets really interesting and honestly a little terrifying.
We're transitioning from the feeling of speed to a mechanism that drives it mathematically. We need to talk about recursive self-improvement.
This is the buzzword that has Silicon Valley either, waking up in a cold sweat or celebrating, depending on who you ask. We've got a report from the Marketing AI Institute that references Eric Schmidt, the former CEO of Google.
Right, he was speaking at Harvard.
He was, and he dropped a bombshell. He said, we are maybe 2 to 4 years away from AI systems that are capable of recursive self-improvement.
Okay, I want to be really, really clear on this because recursive is one of those words that sounds smart but can be super vague. What does that actually look like in practice?
Okay, so imagine an AI system that isn't just answering your questions. It is looking at its own code. It's looking at its own training data.
So it's self-aware, in a sense.
Not necessarily self-aware like a person, but it can analyze its own architecture. It can spot a weakness, say, I'm not very efficient at solving logic puzzles, and it can propose an improvement to its own code. And then, this is the absolute key, it builds a better version of itself.
So version 1 builds version 2?
And then version 2 looks at itself and builds version 3, and version 3 builds version 4.
And because it's a machine, it doesn't sleep. It doesn't take coffee breaks.
It learns instantly. It's like a student becoming the teacher, but the student has infinite stamina and thinks at the speed of light.
But wait a minute. We've had AI for a while now. Why aren't we there yet? What's stopping, say, ChatGPT from doing this today?
It's us. We are the bottleneck. Humans. Paul Rotzer from the Marketing AI Institute had a fascinating insight on this. Right now, researchers at places like OpenAI or Google DeepMind, they're the ones who have to come up with the experiments.
Right. A person has to say, let's try tweaking this parameter and see what happens.
Exactly. They run the tests, they analyze the results, and humans are slow. We need to sleep, we need to eat, we have meetings.
So many meetings.
So many meetings. And Rutzer points out that because of this human bandwidth limit, these labs can only run maybe a few hundred major experiments a year. But he asked the question, what if the AI takes over the research?
If the AI becomes the researcher,
Oh boy.
then they could run 50,000 experiments a year, or 1,000,000, or 1,000,000,000. The loop tightens. The cycle of innovation moves from human speed, which is years or months, to machine speed, which could be seconds.
That still sounds a little abstract, though. Can we ground this? Retzer gave a real-world example in marketing that really made this click for me, because right now, even with all the AI tools I use, I'm still the one clicking the buttons.
Okay, Ray, think about what they call the autonomous agent scenario. Imagine you have an AI running a global marketing campaign. Today, we have tools that suggest changes. Yeah, the AI says, hey, change the subject line, it's not working, or shift your budget to this ad.
And a human looks at it, thinks about it, maybe argues with it, and then clicks approve.
The famous human in the loop.
Exactly. But in a recursive or a fully autonomous scenario, the agent has access to everything, the budget, the creative assets, the email server, all of it.
So it sees an ad as underperforming in Tokyo at 2 in the morning.
And it doesn't ask you. It just rewrites the ad copy, changes the budget allocation from one platform to another, and deploys it instantly. Then it measures the result 2 minutes later and does it again.
And this brings up a huge problem, because if the AI is making optimizations every millisecond, the human cannot physically approve those changes. We're just way too slow.
That is the loss of control risk. That's the big red flag everyone is waving. To get the benefit of that incredible speed, you have to remove the human control. You have to hand over the keys to the car.
Because if you insist on approving every change, you become the anchor dragging the ship.
You're not just an anchor, you're bringing the whole process to a screeching halt. The value is in the speed.
So let's just pause and look at the picture we've painted so far. We have Toffler's future shock. Our biology is already freaking out. We have Rose's acceleration. Our society is already contracting the present. And now we have an engine of potentially infinite acceleration coming online in maybe 2 to 4 years. It feels like we're about to blast off into the stratosphere.
It does. It looks like a completely vertical line on a graph.
And this is the big but. Here is the twist. The engine is hungry, and we are running out of fuel.
This is the data wall, and honestly, it is the most ironic, unexpected problem in the history of computer science.
We have sources here from California Magazine and this projection paper from Epoch AI, and they are saying that despite all this talk of infinite speed, we are hitting a hard physical limit.
To really get this, you have to understand how these large language models, the LLMs, actually work. For years, they've relied on what they call scaling laws.
The scaling laws.
The basic equation has been more data plus bigger models equals better intelligence. You just feed it the entire internet, and it gets smarter. That was the assumption.
But the internet is finite. I mean, it feels infinite when I'm doom scrolling at 2 in the morning, but
Yeah.
there's a limit to how much humanity is actually written down.
Precisely. And Epoch AI, they ran the hard numbers, and the results are pretty startling. They project that we will likely exhaust the entire stock of high-quality language data by 2026.
2026. Wait, hang on. That's essentially now. I have milk in my fridge that expires in 2026. You're telling me the fuel runs out this year or next?
For the good stuff, yes. For the high-quality data, the reserves are almost empty.
Okay, why the distinction? Why high quality? Can't they just, read all the comments on Reddit and YouTube?
Well, they can, and they do. That's the low-quality data. But there's a fundamental difference between random text and structured logic. High-quality data means books, scientific papers, well-written articles, code repositories.
Things with a structure.
Things with structure. A book has an argument, a beginning, a middle, and an end. It teaches the model how to reason over a long sequence of information.
Whereas a Reddit comment or a tweet
Is often short, it's reactive, it's full of slang, it's context-dependent, or it's just plain wrong. If you train a model only on low-quality data, which Epoch predicts runs out somewhere between 2030 and 2050, you get a model that can chat but maybe can't think deeply.
It's like the difference between a university library and a bathroom wall.
That's a great analogy. You can learn something from both, but you wouldn't want to build a superintelligence out of just one of them.
There's a quote from Stuart Russell at UC Berkeley that really stuck with me. He just said it so plainly. He said, "We're literally running out of text in the universe to train these systems on."
It puts a whole new spin on future shock, doesn't it? We felt like information was this infinite, overwhelming flood, but for these machines, it's actually a scarce resource they're about to exhaust.
And it's not just about the quantity, right?
Right.
The California Magazine piece highlighted a researcher named Siwon Min, who argues this is also a quality crisis that leads directly to bias.
Exactly. Current models are trained on what they call medium-quality web scrapes, but you have to think about what's actually on the web. It is heavily skewed toward English speakers, heavily skewed toward Western culture, heavily skewed toward people who have the privilege of internet access.
So if we run out of new, diverse data, the models just keep recycling that same biased worldview over and over.
Right. It becomes an echo chamber. If the training data is dominated by, say, standard American English, the model just defaults to that. It loses nuance. It can't understand other dialects or cultural contexts as well. If you stop feeding it diverse inputs because you've run out of them, it becomes homogenous. It becomes a stereotype engine.
And we're already seeing companies get desperate. There are all these reports and lawsuits about Meta allegedly using pirated book collections or companies scraping YouTube transcripts without consent. It feels like they're scraping the bottom of the barrel because the barrel is empty.
It's a resource grab. It's the new oil rush. Just like the scramble for oil in the 20th century, now we have a scramble for data. But unlike oil, we can't just go drill for more in the Arctic. We have written what we have written. Humanity hasn't produced more history than we've produced.
So we have a diagnosis of speed, an engine of recursive AI, and a fuel tank that's flashing empty. What does the engineers do? They're not just going to give up. They try to engineer their way around the wall.
Exactly. And this is where the proposed solutions get very creative and also potentially very, very problematic. They have three main strategies they're exploring to try and climb over this data wall.
Okay, let's go through them. The first one seems like the most obvious one, synthetic data.
The logic is pretty simple on the surface. If we run out of human-written books, let's just have GPT-5 write a billion new books, and then we'll train GPT-6 on those. Problem solved, right?
Is that a good idea? It feels like a snake eating its own tail. Or like making a photocopy of a photocopy of a photocopy.
It is incredibly risky. The experts have a term for the danger here. They call it model collapse. There was a major study that found if you train an AI on AI-generated content, the quality degrades rapidly.
Why, though? What actually happens to the model?
Think about it like this. Think about dog breeding, or maybe the Habsburg royal family. If you have too much inbreeding, you get genetic defects. You lose diversity. In AI, it's a variance problem.
A variance problem.
Yeah. A human writer is surprising. We make weird connections, we use strange slang, we make mistakes that are actually creative leaps. An AI, for the most part, tends to output the average or the most likely word in a sequence based on its training data.
So if you train an AI on that average output,
It becomes even more average, and the next generation becomes even more average. The temperature of the creativity drops. The model loses its creative spark and just starts to produce this beige, boring, repetitive nonsense.
or it just goes crazy.
Or it goes crazy. It can start to hallucinate wildly because it's lost its tether to the real world, to real human data.
So synthetic data might not be the silver bullet. It might just drive the models insane. What's solution number 2?
This one is fascinating because it fundamentally changes the definition of what we think of as AI intelligence. It's called test time compute, or creating reasoning models.
This is like that new OpenAI o1 model I've seen mentioned.
Yes, exactly. The California Magazine piece cites research from Google DeepMind and Berkeley on this exact topic. The core idea is stop trying to just feed it more facts from books. Instead, give the model more time to think about the facts it already has.
How does a computer think, though? What does that mean?
Well, currently, most AI models give you an answer almost instantly. It's just predicting the next word. But with a reasoning model, when you give it a prompt, it pauses. It breaks the prompt down internally into a chain of thought.
Okay.
It might say to itself, okay, the user asked for a comprehensive marketing plan. Step 1, I need to analyze the budget. Step 2, I need to identify the target audience. Step 3, I should outline 3 potential campaigns.
So it talks to itself before it talks to me. It makes a plan.
It simulates a thought process. And here is the really clever trick. That internal thought process, that chain of thought, it generates high-quality reasoning data. The AI isn't just generating an answer, it's generating the logic to get to the answer. And that logic can then become new training data.
That is clever. So it's like teaching the model how to fish instead of just giving it a fish. You're teaching it how to reason.
In a way, yes, you're engineering thinking time. To compensate for the lack of new reading material, it's a very different path to intelligence.
And then there's the third solution, which I found really interesting because it feels almost biological. This idea of small language models and swarms.
This comes from Dr. A.K. Pradeep, a Berkeley alum, and his argument is basically economic and environmental. He says training these massive godlike models that know everything, from how to bake a cake to how to build a nuclear reactor, is just becoming too expensive and too energy intensive.
And if the high-quality data is scarce anyway, maybe we should stop trying to build one single brain that knows everything.
Exactly. The pivot is to build a swarm of small, highly specialized models. One is an expert in contract law. It has read every law book ever written, but it knows absolutely nothing about poetry.
And another one is an expert in Python coding. Another is an expert in creative writing.
And they talk to each other, just like neurons in a brain, or maybe like bees in a hive. They work in tandem. So if you ask a complex question that needs all those skills, a manager bot delegates the tasks. The lawyer bot handles the legal part, the coder bot writes the script, and the manager bot stitches it all together.
Which bypasses the data wall because you don't need all the data for every model. You just need the specific high-quality data for that one niche.
Exactly. It's a much more efficient use of a scarce resource.
Okay, so bringing this all together, we have the diagnosis of future shock and social acceleration. We have the engine of recursive self-improvement trying to push us to infinite speed. And then we have the break of the data wall trying to stop us dead in our tracks.
It is a race. We are living through a race between software getting smarter recursively and the human-generated inputs running dry.
And if the synthetic data solution works, or if these new reasoning models manage to bridge the gap,
then the recursive loop accelerates. The data wall crumbles, and Toffler's future shock becomes our permanent day-to-day reality. We go vertical. The speed of change completely exceeds our ability to comprehend it.
and if it doesn't work, if model collapse is a real, unavoidable problem,
then we might hit an AI plateau. We might see the progress stall out. We'll get better tools for sure, but maybe not the superintelligence everyone is talking about. Or we shift to that third option, the specialized swarms, which creates a much more manageable tool-based future.
I want to spend the last part of this deep dive talking about where we fit into all this, the humans. Because reading Toffler and Rosa and then these AI reports, I just kept thinking about Toffler's concept of the prosumer. It feels like we're actively feeding the very beast that is stressing us out.
It is the ultimate realization of his prediction. It's almost spooky. In the third wave, he said we would become prosumers, producers, and consumers at the same time. And just look at generative AI.
Yep.
We consume the tools. We use ChatGPT to write emails or code or whatever. But in the very act of using it, we produce the data that trains the next version of the tool.
We are part of the recursive loop. We are the fuel.
We are the fuel. But there is a huge warning here. The expert commentary on Toffler brings up Yuval Noah Harari and his concept of dataism.
Dataism. It sounds almost like a religion.
Harari argues that it is the emerging religion of the 21st century. It's the belief that the entire universe consists of data flows, and the value of any phenomenon or entity, a person, a piece of art, an idea, is determined by its contribution to data processing.
So if it isn't data, it doesn't matter.
In that worldview, yes, Beethoven's Fifth Symphony. It's just an efficient pattern of data, your feelings of love for your family, just hormonal data processing. And the risk is that human agency, our free will, gets replaced by a blind faith in the algorithm.
We trust the machine because we believe it has processed more data than we ever could. We defer our judgment to the superior processor.
And we lose something essentially human in the process.
Which brings us right back to Hartmut Rosa's pace of life. If we surrender to dataism, we're just running on the hamster wheel to generate more data to feed the machine. So how do we stop? Or at least how do we cope with this? Is there a way off the wheel?
Toffler actually proposed a solution way back in 1970. He called it anticipatory democracy.
Anticipatory democracy. Okay, that sounds a little bit like political jargon. What does it actually mean for a normal person listening to this right now?
It means we cannot just be passive bystanders. We can't just stand on the beach and let the wave of the future hit us. We have to actively reshape our institutions, our schools, our governments, our companies to match the pace of the technology. We have to anticipate the shock.
Okay, give me a concrete example. What does that look like?
Take education. Right now, our education system is, for the most part, still built for the second wave, the factory model. You sit in rows, you memorize facts, you pass a test. But in a world of recursive AI, memorizing facts is basically useless. The AI knows more facts than any human ever could.
So anticipatory education would be?
What? Teaching adaptability. Teaching AI literacy, not just how to use the tool, but understanding how the machine thinks. Teaching critical thinking so you can spot when the AI is hallucinating or biased. It means preparing kids for the shock before it hits them.
And what about in our jobs? Or in government?
It means regulation that isn't 20 years behind the technology. But on a personal level, it means demanding transparency. If our data is the fuel, we should have a say in how it's being used. It means fighting to ensure that efficiency isn't the only value we chase. There's also meaning and connection and, just being human.
There was a great line from the LSE review of Rosa's book. It warned against what it called the Grand Hotel Abyss.
Yes. That is such a haunting image. It's a reference to the philosopher Georgi Lukács. He was describing the intellectual class of his time, and he said they had all checked into the Grand Hotel Abyss.
So what is that?
It's this beautiful, luxurious hotel, equipped with every possible comfort, great food, jazz music, fantastic views, but it's sitting right on the edge of an abyss, on the edge of nothingness.
So they're just eating steak while they watch the world crumble.
Exactly. They contemplate the abyss, they analyze it, they write brilliant papers about it, but they do nothing to change it. They're just enjoying the beautiful view of the destruction.
Oof. That feels like a direct call out to, to us right now.
Yeah.
We're sitting here analyzing the end of data and future shock, but are we doing anything about it?
That is the warning. Do not just observe the speed comfortably. Do not just analyze the acceleration from the safety of the hotel. You have to actively engage with the direction of it, because if you don't try to steer the car, the recursive loop will steer it for you. And the machine does not care if you get motion sickness.
So as we wrap this up, let's look at that contracted present one last time. We're living in this bizarre moment where the future is arriving faster than we can even document the past.
And the data wall is the most important and maybe the most hopeful check on that reality. It isn't just a technical glitch. It is a profound reminder of the fundamental value of human creation.
That's the beautiful irony of it all, isn't it? These incredibly powerful machines are hungry for what we know. They are desperate for our books, our articles, our messy, illogical thoughts. They are running out of us.
It really suggests that true intelligence, not just pattern matching, but real intelligence, requires experience. It requires the messiness of living in the world, of bumping into things, of feeling pain, of feeling joy. That's what generates the novel data. The machine can optimize, it can compress, it can accelerate, but so far it cannot create the raw fuel of lived experience.
And that leads to a really provocative final thought for everyone to chew on. If the machines do figure it out, if they figure out how to generate their own synthetic data that actually works and isn't just an inbred copy, if they close that loop, do they still need us?
That is the multi-trillion-dollar question, isn't it? But looking at all this research into model collapse, that inbreeding problem, it really seems that if you completely remove the human input, the system goes mad. It starts to hallucinate. It drifts off into the abyss.
So maybe the data wall proves that Human experience is the one non-renewable resource that intelligence actually requires. We're the anchor to reality.
We are the anchor, and in a world of infinite acceleration, an anchor is a very, very valuable thing to be.
So, to everyone listening, don't just be fuel for the algorithm. Be an anticipatory participant. Don't just watch the speed. Try and grab the wheel.
Couldn't have said it better myself.
Thanks for diving deep with us.
Yeah.
We'll see you in the next one, assuming the timeline hasn't completely collapsed by then.
I'm betting we'll still be here.